Hi, I'm Michal Davidson, and today I'm going to be speaking about cloud security domains. So, a little bit about me. I'm currently a software and security architect at Dell Technologies, where I lead public cloud and security for PowerFlex, our software-defined storage product. Previously, I've worked in a number of different companies as a software architect and security architect, and I've been a lecturer for cybersecurity at a number of colleges. Today, I'm going to be speaking about security domains on the cloud. I'm going to start with a very short introduction on security domains so that we then understand what we're doing in the cloud. So you may have heard my previous talk as part of the security DIL, where I said that we need to stop looking at security as this big blob security and rather break it up into domains. And the motivations for that are that, first of all, and most importantly, it's going to provide us with a holistic view of our system and make sure we're not forgetting certain aspects of security because we're so focused on other aspects of the security domain. And that's what I'm going to be mostly focused on today. In addition, I said that breaking up security in domains enables us to create communities around different domains. It also enables us to battle imposter syndrome when we are very good at a certain domain and may not have full knowledge of a different domain, by understanding that it's quite challenging to know everything. So today what we're going to do is I'm going to explain again briefly what the different security domains are, and then we'll see how that applies to the cloud. Now, once we've applied that to the cloud, we'll also be able to discuss the various security tooling options which are currently on the market and see which problems they're going to solve for us and which problems are still open. Following that, I'll discuss some rules of thumb for how you can approach deploying your system on the cloud. So what I did with security domains is I broke up into these 6 domains. You're welcome to break up a different way. The main thing is that we start making sure we think about all aspects of security in our system and don't leave some as gaps. Now, an aspect that gets a lot of attention is compliance, which is making sure that we're compliant with certain security standards. We have federal compliance, we have GDPR around privacy, we have financial compliance, and I see that as a domain within itself. Moving on, network security gets a lot of attention. Before the cloud, you would often hear discussions about network security in terms of security gateways and firewalls. Nowadays is more focus on identity and access management and single sign-on and multi-factor authentication. I kind of like to tie identity management and network security together because they're all about denying or authorizing access to the system once you're authenticated. Doesn't matter if it's via SSH, SSL, or SSO. Reverse engineering is a field within itself, and that's something I tried to show in a previous talk, because reverse engineering is really that sitting down and finding the flaws in the system. It could be cryptanalysis of cryptography, it could be white hat hacking, it could be pen testing, any way of identifying the flaws. And that's a very important mindset for everyone to have when designing security, not only to think, how do I build the best security system in terms of the functionality, but also think, what about the edge cases? What about the users who are trying to actually subvert what we set in place? And you really do need that mindset in order to be a good hacker. But I did want to stress that hacking is not necessary if you want to enter the cybersecurity industry. There's so much other work to do. So don't let that stop you. When it comes to monitoring, this is where we're going to see with the cloud security tools so much focus in the cloud security space. I would say that's because both the risk of not monitoring your system when it comes to the cloud, there's so many misconfigurations that happen, and the scale of cloud that really can no longer rely on manual administration and manual monitoring. It does need that monitoring in place. And that's where we're often using machine learning tools and data science in order to analyze everything and detect anomalies. When it comes to cryptography, for me, that's what I most love about security. And that's the real essence of security is based on cryptography. And when it comes to the cloud, it's fascinating to see that the same cryptography issues and challenges remain in place. They're just moving to a new space. So if until now we were thinking about protecting our keys, we're still doing security and performing cryptography securely, we're still going to be doing that. But now we have to think, how do we protect those keys in the cloud? How do we protect our crypto in the cloud? How do we distribute keys in the cloud? But we no longer typically have that reliance on hardware security. Now, there are options for hardware security and HSMs in the cloud hardware security modules, but they are costly. So I'm typically seeing them being used when companies care about compliance and there is some requirement for hardware security. Otherwise, companies are usually going to prefer to use some kind of software method. Security architecture is where a lot changes when it comes to the cloud, because we're still taking everything, all the information we have, and trying to do a security review, threat modeling, but now we need to think about the additional attack vectors and the additional challenges that we mentioned, like no reliance on hardware, having our keys in the cloud, etc., the new network security in the cloud. In terms of secure protocols, I'm listing specific protocols for the cloud, rather the reuse and adoption of protocols that already exist, such as SSO, OIDC, SAML, TLS, etc., being implemented in the cloud, but we need to review, are they really being implemented securely? And when we're designing those protocols, we need to think, are we relying on hardware, or do we have something in place for the limitations of the cloud and for the scale of the cloud? So now that I've quickly run through the security domains, I want to touch upon the cloud security challenges, and then we'll see how the current tooling in the industry exists in order to support those challenges. So take a second to think for yourself what current challenges are. I'll touch on a few. It could be there are a lot more challenges you've thought of. You're welcome to drop them in the comments. One of them I already mentioned, which is the limited hardware security, because it's expensive and difficult to use, and really that reliance on software security. A challenge also to create a unique identity in the cloud once you're talking about VMs or containers and you don't have that anchor in hardware security, not only to not protect keys, but even to create a non-clonable identity. Key protection can also be challenging in the cloud once we're relying on software. Multi-tenancy is a huge issue in the clouds, with most SaaS tools trying to be multi-tenant. There's obviously increased exposure, because if until now, sometimes at least when it came to storage data centers, you could rely on at least some physical layer of protection and a network layer of protection, because you have to actually get into those private networks. Now we're talking about VPCs on the cloud, one VPC misconfiguration, and all your assets could be exposed. We then have ingress and egress traffic, because let's say that your virtual private cloud is protected, not misconfigured. How are you protecting the data going into the cloud, coming out of the cloud? And a big challenge that I'm seeing is when it comes to the multi-cloud, because while every single cloud vendor does have solutions in place for that on-prem to cloud traffic for their cloud, because that's something they really want to help customers do. They want customers to take the data and move it into their cloud. You're not seeing any out-of-the-box solutions for traffic from one cloud to another cloud, at least not easy solutions, because no cloud vendor has it in their best interest to help you migrate their data to another cloud. So none of them are helping us do that right now. And I think that's a really big challenge in general, where we're seeing this move to multi-cloud. We're seeing the majority of the companies are using multi-cloud. Over 90% of enterprises are planning to use multi-cloud, and we don't have good cloud vendor solutions for the multi-cloud security. But that will leave for another day. So in terms of cloud vulnerabilities, what you used to think about when you heard cloud and you thought vulnerability was really around the shared tenancy of the machines, about secrets leaking from one machine to another, privacy, when data could leak from one machine to another. But then the cloud vendors put in a lot of effort to make sure that doesn't happen. And what we see here in this analysis is that would require a very sophisticated level of attack, and so the prevalence is quite low. The majority of attacks are actually around misconfigurations, which is actually when the user makes mistakes. And that's what really drives the majority of tools for cloud security that we're going to see too, trying to present these misconfigurations on the cloud. And that's something important to keep in mind, because while that's important, let's not forget that we still do have other security domains and other aspects of our system that we want to protect. So let's touch a bit on cloud security tooling. Now, I admit that when I came into the cloud security space and I saw all these acronyms, I was a bit overwhelmed. I mean, we're talking about a lot of 4-letter words now, and now we have these 5-letter words, CNAP. Okay, what we're going to do is we're going to run through these tools. And what really helped me was understanding which category of security domain every tool fit in. And that way we could understand what it's covering, what problem it's addressing, and what still remains open. So the CSPM is Cloud Security Posture Management. That's a tool that's going to look at your cloud configuration, including your network security, your firewalls, your security groups in AWS, and it's going to say, I detect some kind of issue here. We have, for instance, AWS Security Hub, Microsoft Defender, that could, and these are useful tools, but what we see here is that they're addressing network security challenges and they're performing monitoring for them. Moving on to the Cloud Access Security Broker. Cloud Access Security Brokers sit between the user and the cloud app, and they enforce policies around data protection. Now, they're very helpful for shadow IT because we do know that the majority of users nowadays don't only use their own enterprise IT, they install applications themselves. I'm sure if you ask yourself, did I install applications aside from what my IT recommended, you're going to be saying yes. Right? Also think, for instance, of Gmail, of Google Drives. If that's not what your enterprise is using, that's shadow IT. So the CASP goes and monitors any data that's going from the enterprise into the shadow IT, and it can actually prevent that data being migrated, and it can mitigate data loss or security breaches. Now, I'm not going to get into the modes here of use. We do have the proxy mode, the reverse proxy, and the API mode. What I wanted to focus on here is, again, we're focused on network security because I tied in the whole issue of identity and access management with network security. Let's move on to the CWPP, the Cloud Workload Protection Platform. This is a lower level in the work chain. It provides more visibility and insight, and it's typically agent-based. It allows workload protection when moving between cloud environments too, which is very good for multi-cloud if previously I mentioned the multi-cloud challenges, and integrates very well with CI/CD and with automated protection of containers, which ties in with DevSecOps. Now, we do need to think what actions are taken if the CWPP discovers an issue. But this is actually a very good solution. But let's again see what domain is it's tackling. It's tackling the monitoring of the user behavior, of the workloads behavior, of the services. Moving on to the SIEM, I mean, this name you've got to love because this is not SIEM, S-I-E-M, Security and Incident Event Manager. No, this is CIEM, which is Cloud Infrastructure Entitlement Manager, because they're really trying to confuse us here. Yeah, make like a really high entry bar for entry. Anyway, so what does the SIEM do? It manages the access. It's a tool for managing this access and enforcing least privilege. Now, 50% of cybersecurity professionals said that unauthorized access is the threat that scares them the most. That's something we saw in the cloud security report. It's not really needed for a single cloud, but again, this is useful for multi-cloud. So when enterprises are moving to the multi-cloud and they're seeing that what they have provided by the cloud security vendors is not enough, they're going to go and they're probably going to add SIEM. Again, what we see here, though, is the monitoring and the network security. Now, it can apply zero trust principles, because it is able to actually monitor the access and possibly tie in to a policy administration point and have like local policy enforcement points. So this can be a very useful tool. Last of all, we have the CNAP, 5-letter acronym, the Cloud Native Application Protection Platform, which the goal here is to consolidate all 4 platforms. But now we've seen that all of these 4 platforms are solving only the network security and monitoring problem. We're seeing also the wonderful CNAP, which is saying I'm consolidating 4 tools together, is again only solving network security monitoring, which means we do have these other domains still left to address. And that was why I wanted to show here that we still do need to care about all security domains when we're looking at the cloud. So let's look a minute at cloud security from the vision of domains. We saw before that the CWPP, CSPM, and CNAP kind of tie into monitoring, and I've put the CASP over here. There are additional network security things that we need to care about in the cloud, such as our virtual private cloud, configurations of the virtual private cloud, security groups, the connectivity that I mentioned before into the VPC. But in addition to that, I think it's worth taking a look at cryptography and the architecture and compliance. When it comes to cryptography, let's think about how we're managing our keys, understand the underlying key management infrastructure, the KMS that every cloud vendor provides, try and think, do we need to make use of a hardware security model in HSM, and really try and use data at rest encryption whenever possible, as well as data in flight encryption, even within the VPC. Because if we spoke before about that risk of misconfiguration, even with these monitoring tools, that's still a risk. So wherever and whenever you can protect that data, that's really recommended. In addition to that, we're seeing the importance of the cloud security architectures, and the well-architected framework, for instance, by Amazon really focuses here on security. And we do have cloud-specific compliance guides. Now, in terms of the privacy and the GDPR, one big thing I'm seeing is the region issues where you don't want data to cross regions, but we also have the specific ISO 27017, which is focused on cloud security. And I do think it's worth taking a look at the shared responsibility model. Now, I don't have time to touch on, go into the cloud security shared responsibility model now, but that's something I really recommend that you do later. I'm going to end by sharing with you my rules of thumb for adopting a good cloud security approach. First of all, avoid lift and shift. Now, this can be tempting if you're taking your system and deploying on a cloud, and it's something that can actually work very well when it comes to just taking your containers and shifting them, taking your instances and moving them, that can work. But when it comes to security, please reevaluate, identify the risks, because it could be that a risk that was low on-prem because you did have the additional physical security and additional network security of on-prem. Once you're on the cloud, you're going to have increased exposure, increased vulnerability to misconfigurations, and it's worth investing in a higher level of security, such as data in flight and data at rest encryption. My second piece of advice is zero trust is always important, and but it really, let's remember that one of the motivations for zero trust was migration to the cloud, because when it comes to the cloud, we really do need to have these centralized identity-centric policies where access can be given based on dynamically evaluating the context of each request. We don't want this static deny and allow across everything. We really want that fine-grained control and that linkage with single sign-on, with context-based controls, and with risk scoring, who is accessing what and why. So it's worth investing more in zero trust security when you move to the cloud. Security automation is very valuable in the cloud. If until there was a lot of hype around DevOps, now the new industry is actually DevSecOps. Let's take security, shift it left to automate as much as possible. Now, when you do that, do think about your infrastructure as code, and do think about when you have automated incidents response, remove alert fatigue. You don't want to have too many alerts about too many security warnings that aren't important, because then you're just going to ignore everything and it's not worth much. Last of all, use cloud security, cloud vendor services wherever possible, such as the Security Hub, the CSPM, CM, Guard Duty, for instance, in AWS. These are valuable, just understand they're only covering a small area of your security. And then take a look at the AWS shared security model if you're deploying there, the Azure shared security model. And what I really like is Google's shared responsibility and shared fate, which is trying to say Google itself are trying to take responsibility with the customer to ensure they have a shared fate. It's in the cloud vendor's interest and in your interest to make sure that your system is secure. So thank you very much and have a good day.